chances are if you're watching this video, you have a bouncy floor and you want to do something about it, or it's sagging and you want to do something about it. Let me tell you what's going on. Most houses are built to the minimum standard. That means that it was just built to the minimum standard or the minimum code maybe, but minimum standard doesn't necessarily mean it was built with any code. It could be minimum standard, industry best practices, but doesn't mean it's really to code. But who wants minimum? Minimum standard is not always the best thing for the purchaser. Now, so here's a mock-up I want to build of your floor here. So what's going on here? These are my floor joists, if you'll look at these, and that's not to scale, of course, but so these floor joists right here, what happens on your floor is it sags over time. It could be due to moisture, as was in the case of mine, so it's not always the builder. It was in the case of mine, so that was part of the problem. Another part of the problem was I didn't have sufficient pillars placed under my house because it was built to minimum standards. Now, what happens on the floor when it's bouncing, these joists right here move this way and that way. Not so much straight down, but they deflect this way and that way. The deflection is the movement up and down the floor. So there's a couple ways you can fix it, or actually 3 or 4 ways you can fix it. And what you can do is you come in and you put in these, make sure you have these blocks, and these should be in under your crawl space or in your house. So you have these blocks under, so here's your subfloor. If you look under, you'll see that you have these bracing blocks, and there will be another one, of course, over here and whatnot. But make sure you have those. Those are very important for deflection. If you don't have those, you got to start there for sure. But that's one thing that would remedy it, although it's not going to eliminate it. But that's one way you could do it. Another thing you can do is you can come in and you can just go up under your house and you can just put another piece of OSB or plywood or whatever you want to do. Let me do it this way. So you can come in here and you can just put basically another piece of OSB up under here, and you can just sandwich, you might say, now your floor. The only problem with this is now you have a lot less headroom. You've reduced that. Now what I did, I went in and I put in what they call smart jacks, and these jacks are not smart. They're just a way you can adjust the jack. It's a floor jack, a jack post, lally post. I don't know what they're called, but they're smart jacks. It's what they're called, but you got to make them real strong. So what I did was, here's my floor. So let me show you what I'm talking about. So you can take this, here's your floor, and I took and put me more pillars, it's out of the way. So I got 2 pillars here. I come and I put a beam, a 4x4 post, 6x6, steel beam, doesn't matter, whichever something that's going to reduce, give enough strength to reduce the deflection. So now here would be your floor up under the house, and this thing would be, of course, mid-span, like that. So these right here would pretty much, that would eliminate deflection and sagging. You could raise the floor, although you don't want to raise the floor all at once, and you might not want to raise it at all. You just want to stabilize the floor. But that's what I chose to do in this video. Now, in preparing that, you're going to need a footing for each one of these jacks to rest upon. So when I built my jacks, what you have to do is you want to come in, and for each pillar, you want to have a good footing. The footing they recommend, if you looked at all this up, is a 2 foot by 2 foot by 1 foot deep hole if you're using 4,000 PSI concrete. Those out there that know more than I do, you can comment below and say, hey, you should use rebar, you should use whatever. That's fine. You probably know more than I do, I can guarantee you. But I did a 2 foot by 2 foot by 1 foot deep hole using 4,000 PSI concrete. You can use a 2 foot by 2 foot by 24 inch or 2 foot by 2 foot by 2 foot deep hole if you want to use engineered stone. And what that allows to happen is you got to take the weight from the floor and distribute that down the jack or the pillar and into the base of the jack, into the bulb of influence, they call it. But you got to disperse that energy down into the soil. But it's got to be enough to hold, your soil has to be enough to hold that, and your footing is what does that. You wouldn't just come in and put these jacks. I see a common thing, and I've done this too. A common thing is to come in, you get a block, you sit that down on the ground, you put a jack post, you put it in. It's going to fail over time. It might work in some cases if you don't need much, but if you're trying to take stress off your floor, it's not going to work. Eventually your block's going to keep sinking and keep sinking because, again, you haven't addressed the problem of the footing, which is the problem you have now, as well as other things that can cause this issue. But anyway, that's what I did. Hope you enjoyed the video. Let me know what you think about the jacks. Let me know what you think about what I did, what I could have done better. I'm sure there's better ways to do this by far than what I did, because I'm telling you, it was An exercise I don't plan to do anytime soon, so. Where's my cut at? So I'm going to cut out a 2 foot by 2 foot, 1 foot deep hole in the ground here because I'm going to be using concrete. Now you could do a 2 by 2 by 2 foot hole if you want to use engineered gravel, they call it, which is a fine stone. You can use that, but I chose to use concrete, so I'm digging a 2 by 2 by 1 foot deep hole. Might be something dead here on here. That's a drain right there. We'll just dig out around that. So I'm going to use my Bosch Bulldog hammer drill to dig out this hole because, man, this thing saves you a ton of time. All we have to dig with, because the crawl space is kind of small, all we have to dig with is the hammer drill and the shovel that I'm using there that you see that has no handle in it. So, and your fingers, that's all you got. And we're going to take this thing out, all this dirt, 1 bucket at a time, 7 buckets per hole. So we'll get this done. I made this cart that you're going to see here, this moon buggy I call it, but I took some 10-inch pneumatic tires that I got from Harbor Freight, built me a little cart there to haul this out, and you can see my son Nathaniel there helping me 1 bucket at a time. There are 7 or 8, depending on how much dirt you can get packed in the bucket, 7 or 8 buckets per hole, and we had to dig 5 holes, so we carried that roughly around somewhere around 40 buckets. But so yeah, it was just painstaking. We put this little ramp to go out the crawl space. My son, this kind of was his idea, like, hey, this is way better than what I was fixing to do. But yeah, this worked really good. This was a back-breaking exercise, but man, if we hadn't had this right here, it would have been way worse. So here I chose to mix the concrete in the hole because, as you can see, this dirt packs really a lot in the crawl space. So I'm gonna mix the concrete up in the hole, filling with water, and you'll see it's gonna work just fine. I'll give you a quick in here. Keep adding a bag at a time. I'll use the shovel at first to just kind of mix it in really, really well, and just keep doing this right here, and we'll get the drill out here in a little bit, and just keep going. We are wearing respirators at this point too, so want to make sure we don't breathe in any concrete, silica. What was I doing? That ship has sailed now. I said that ship has sailed now. At least for right now. I said at least. Here my son and I are discussing right now, and what I'm upset about it here is, at least this was supposed to be a 2 foot by 2 foot wide hole, but because of where the pillar is located there, as you see, I didn't quite get the 2 feet I wanted, but luckily this is not the most critical jack, but it's still going to have actually about a one and a half, almost a 1.5 deep, 1.5 foot deep hole here, so it's not going to be a big deal. But that was why I was so upset, because I thought I got it 2 foot by 2 foot for whatever reason, and wow, I just choked on this one. So even though I have the almost 2 foot wide pillar, but an inch or a foot and a half or so deep, I got to smooth this top off pretty good. And we're using this highly calibrated shovel head here, as you can see, to do that with, because I'm going to put a couple of blocks of 4 by 16 inch blocks on top of this pad here, and then I'm going to have the jack on top of that.
Okay. Here.
So now I'm going to start cutting out my stock. I'm using a 1/4 inch plate, 8 by 8 inch plate for the base, and I'm going to cut that with this porta band saw here. And I'm also going to make these round 1.5 inch or so pieces that I have another 1/4 inch plate, 5 by 5 inch on top of this welded this pipe you see here. And all this is for is a freewheel up under the beam that's going to be resting on the jack. And here I'm just going to clean up the pieces, get the burrs out real good before I start welding. Just going to tack it right there for now. I'm going to be using a Schedule 40 pipe to weld to the 1/4 inch base here, and this is really strong. It's almost a 3 inch diameter. It's 2 point, I forget what it is, but yeah, it's pretty healthy pipe. I wanted to make it really, this is way overkill, but I did that by its own purpose. So just you see why we make grinders now when I was welding here. So All right, so I've got the base welded here, get the pipe where I want it, and the top plate, the 3/4 inch or 3/8 inch plate. And what I'm going to do is I'm going to run this down here, and this nut is going to sit in here. This, of course, be welded all the way down, but I'm going to take real care. I'm going to line it all up so my flat, this is just a me thing, but flat, flat, flat. That's just me, but anyway, that's where I'm going to go weld this nut on now. I'm gonna put a little tack on it first. This is a harder steel than the carbon steel that I'm putting on. As you can see, I'm using a 6013 rod here. I really wanted, I probably should have went with a 7018 right here, being the two. It's no big deal. I could have just done a lot better. Well, that wheel looks like garbage, but we'll keep going. Fill this gap right here. All right, so here's the finished jack. So I'll tell you what the parts of this thing. So this is the top plate that's going to rest up on the below the beam that I'm putting in. The screw here, you can go 10 inches if you want to adjust it. I'm not going to be going 10 inches. If I did, I'd be busting the ceiling of my house. But you can see these, you screw it in as you screw it where you want to, and so forth. And when I get on the house, I'll put it on and raise it where I want to. Now, 1/4 inch thick plate in the bottom. I got schedule 40 steel pipe right here in the middle, and each one's made a little bit different. 3/8 plate here, 1.25 inch nut. The nut here is probably the strongest thing of the entire jack. It's I think rated 100 and I want to say 125 or 135,000 psi. I don't remember, but it doesn't matter because the all thread that's going inside here is not rated that high. It's probably around 70 or 75,000. So having said all that, I made all this steel 1/4 inch thick, schedule 40, 3/8 plate. That does absolutely nothing for the strength of my jack, because the only thing where all the pressure is going to be is at my all thread on the jack. So whatever the all thread collapses, because this is stronger than the all thread, if this collapses, then the jack fails anyway. But I'm okay with that because I want it strong enough, because if the force is, so I wanted the jack to be made where all the force was going down on the all thread, straight down, all the way down. Because all your strength in this is going to be this way. And then that's why I didn't have to be welded super great, even though I did weld it the best I could. I wanted to build it like a tank, you might say. But anyway, that's what I did. So I hope these will work. So now I'm just going to tighten these right here up. I've got one here, another one down there, and 2 more down here. We'll tighten these up. Everything's lined up, and we may have to shim in some spots where it's touching, not touching the beam's not touching the joist, like right here. We'll shim here, but we don't want to push it too much because I don't know what's going to do up above. So There you go. So I'm going to go through right here, and I'm putting in the shims where the gaps are, where the joist meets the beam that I have. What you don't want to do, and it's what I'm not doing here as well, but what you don't want to do is I'm not trying to raise the floor. I'm just trying to reduce the amount of deflection and to reduce or make it more stable, reduce any kind of bounce or whatever, and it really done a great job. But you see where the beam touches the joist under the jack, you want to be careful raising anything up and do it gradually, because if you don't, you'll bust something upstairs or inside the house. So you got 1, 2, 3, and there's another one that you can't see way down there. We're just tacking it to the joist through the beam at this point here, and yeah, that'll be good.